Hello, everybody. We're back again with the second lesson, second video of geometry here, and this one's about line segments. So we'll give you some notes, some examples, and hopefully that'll get you started on this topic. Let's start out by what we're talking about when we're talking about the distance between 2 points. So the distance between 2 points on the number line. So we'll tell you what it means, and then we'll show an example of that. So we're talking about finding the absolute value of the coordinates of the points. So if we have a line segment like this, which is line segment AB, and let's just say the coordinates for those 2 points are small a and small b, then I want to say that the length of this segment, which is also the same as the distance between those 2 points, the length of that segment, the length of segment AB, is the absolute value of a minus b, which is the same as the absolute value of b minus a. So it doesn't matter what order you subtract those coordinates in. Once you take the absolute value, you're going to get the same number, which is how long that line segment is, the length of that line segment. So we need to talk about a little bit about notation. So if we write AB with a segment on top, that's talking about the segment AB. That's the actual line segment. But if you put the letters AB with no bar on top, that means the length of segment AB. So we're really fussy here, and math is really fussy, and we're fussy with notation. So repeating that, segment AB, when you're referring to the actual line segment, has to have a bar on top, a line segment symbol on top of the 2 letters, the endpoints. But if you remove that bar, then you're talking about how long that segment is. Okay, so let me put some numbers with that. So let's say that we have a number line, and we got some points on that number line. And let's say that point E right here is at -4. And point F, moving towards 0, is at -1, and then maybe C is at 2. Okay, I'm not going to fill all the numbers in. It's not important. So let's say that I want to calculate EF. How long is segment EF? Remember, we can just take the coordinates and subtract them and then take the absolute value. So we can say it's the absolute value of a -4 minus 1. Well, you know that's, oops, sorry, redo. A -4 minus -1 absolute value. So it's the absolute value of a -4 plus 1. So it's the absolute value of -3, which is 3. So we found the length of segment EF by subtracting the coordinates and then taking the absolute value. But what if I just reversed that calculation? So let's say that I did this time the absolute value of a -1 minus a -4. So that would be the absolute value of a -1 plus 4, which is the absolute value of 3, which is 3. So to find the length of a line segment, just subtract the coordinates of the points, the endpoints, and then take the absolute value, and that'll find you the length of the line segment. Or another way to think of it is the distance between those 2 points. Okay. Okay, so what's coming next is another postulate. No, we'll do one more thing before we do that. Let's talk about congruent segments. Congruent segments. So we're going to have use that word a lot this year. Congruent segments. And what we mean by congruent segments is that they are two segments that have the same length. So if I drew a couple segments here, and this first segment is segment PQ, segment PQ, and this other segment is, let's say, segment RS. If they have the same length, then we would say that segment PQ, and again, I need the bar on top there, segment PQ is congruent to. So there's your congruent symbol. It's an equal sign with a little wavy line on top. Segment PQ is congruent to segment RS, like that. And so we can signify that by putting little tick marks on these line segments. So that little tick mark means that those two segments are congruent. And as we know, when segments are congruent, that means that their lengths are equal. So another statement we could write about the situation is that the length of segment PQ equals the length of segment RS. So notice that this is fussy here, but segments are congruent, but their lengths are equal. So there's a difference there. So there you go, congruent segments. Okay, now I wanted to give you that postulate I just mentioned. This is called has a name actually, the segment addition postulate. We're going to use this a lot on our assignment, both our next two assignments. So this is the segment addition postulate. I think it's pretty easy to understand. The segment addition postulate just says that if you got a line segment, let's say line segment AC, and you have some point in between points A and C on the line segment, let's just call it point B, like that. All it says is that you could add up the two smaller segments to equal the longer segment. So the length of segment AB plus the length of segment BC equals the length of segment AC. Might be one of those things that are obvious, but it's a postulate. You don't prove it. And so there it is. The two smaller segments add up to a larger one. And we do that with angles also later on. Okay, so we're going to use the segment addition postulate to solve some problems today. And I'll give you my next example. All right, let's say we have segment RT. Somewhere in between, not necessarily in the middle, but somewhere in between is point S. And let's say that entire length of that segment RT that we started with is called 4x, whatever that x is, we don't know. And let's say that RS has a length of 2x plus 7. And then ST has a length of 28. So the job for us is to find the length of segment RT. So find the length of segment RT. So if we look at that, we know that if we find x, we'll just multiply by 4, and that'll give us the length of segment RT, because segment RT is 4x. So we know from the segment addition postulate that if we take the length of segment RS, which is 2x plus 7, and add to it the length of segment ST, which is 28, that's going to equal the total segment, which is 4x. Now here's a little bit of the algebra we do this year. So I'm going to add those numbers. So you got 2x plus 35 equals 2x. I did two things at once there, algebra students. You know what I did there. I subtracted 2x from both sides and added the two constants. Let's see. Did I make a mistake on this one? 28 4x. No, whoops, yeah, I did make a mistake. So that's not going to work out. When I subtracted those two x's, it's gone from the left side and you just get 2x on the right side. Okay, so sorry about that. So x is 17 and a half. I'll just write it as a decimal. It doesn't matter because we're not done yet. Because remember, we're trying to find the segment RT, so we got to multiply that answer by 4. So segment RT equals 4 times that x we just found, 17.5. All right, so that's going to give us 70. So the length of that segment RT is 70, whatever, inches, meters, whatever you want. Okay, we got a couple more definitions I need to tell you about, and then we'll go to our next assignment. So first of all, we need to know, what is a midpoint? Well, maybe that word just tells exactly what it is. Midpoint of a segment. That's the point in the middle, right? So it's the point that bisects. Here's another vocab for it. Bisects means to cut into two equal pieces. Bi means two. So the midpoint of a segment is a point that bisects the segment into two congruent pieces. So that's the midpoint of a segment. So if I have a segment AB, and I get the point right in the middle, I'm just guessing where it is. I didn't measure that. Just call that M. Then we would say that M is the midpoint of segment AB. And we could show that also by these tick marks, remember, that show you that segment AB is congruent to segment MB, because M is the middle, divides the segment into two congruent pieces. Okay, one more thing along with that, and then I got a couple examples from our assignment from the actual worksheet that I'll work with you. And that is segment bisector. What is a segment bisector? Well, some of these words tell you exactly what they mean. Segment bisectors, any ray segment or line that intersects a segment at its midpoint. So to put some examples with that, let's say that I've got segment AB here. I'm going to write that out 3 times because I just gave you 3 ways to have a segment bisector. So this is segment AB. The midpoint is M. Same thing for all these. I'm just writing a few of these out ahead of time. So any ray that intersects a segment at its midpoint, so this ray right here, that would be a segment bisector because it bisected, it cut segment AB into 2 congruent pieces. A different segment. So this segment right here, that segment called XY. So you can say that segment XY bisected segment AB because it went through its midpoint. And you could have another line. So we'll just say Let's call that line L. Oops. So line L is a segment bisector because it passed through the midpoint of the line segment. So it's a segment bisector. Each of these situations each of these segments had a midpoint, and the line, ray, or segment went through that midpoint, so bisected that segment AB. Okay, that's the notes, but what I thought I'd do to get you started is if you look at our assignment from it's in Google Classroom, you can just follow along for this for now if you want, but I'm just getting this assignment just so you know from line segments version 1. So when you go to work that, you don't need to redo this problem, just recopy it because it's on this video. So, but I wanted to pick out a couple that are similar to what you're going to have to work here. So let's look at segment QT. Some of these require some thought, which is good. And I got a couple points on there. There's point R, and there's point S. So we got 4 points that we know. QR is 12. ST, that's this part right here, is 2x minus 21. This piece here, QS, is exactly 15. And then from RT, that's x minus 6. So you got a whole bunch of different lengths of line segments that you know, and our job is to solve for x. You might have to look at that for a while. But if you look at it, you'll eventually see, hopefully, that segment QR plus segment RT, that's the whole thing, right? That's QR plus RT adds up to the whole segment, is going to be equal to segment QS plus segment ST, because QS and ST also add up to the whole segment. So you can write an equation from that information and then plug in this information that you're given, and that'll set you up an equation which you can solve for x. So QR, we already know, is 12. RT is x minus 6. It's hard to tell from my drawing. You can look at that on your worksheet. You'll see that better. So that's equal to QS, which we see from our problem is 15, plus ST, which is a 2x minus 21. So there you go. There's a algebra 1 equation to solve to help you solve this geometry problem. That's why we require algebra to come before geometry. So you can see we're going to just solve that equation for x, and then that's all they want. So what do we have here? X plus 6 on the left side. Then the right side we got 2x, what's that, minus 6? 6 equals, okay, I'm going to subtract x from both sides. I'll do one thing at a time so I don't lose anybody. I'm subtracting x from each side. Why do I have a double equal sign there? So subtracting x from both sides, so 6 equals x minus 6, and then x equals 12. So that's what they wanted. Okay, I got one more for you as an example from that worksheet, line segments version 1. Again, and it's another freebie here. And this is number 13 on that sheet. And so the directions there, and you can read it when you look at that, or you could even pull it up right now. It just says that you've got points A, B, C, and D are collinear. So when I hear that, the directions all say in that order. So I'm going to put points A, B, C, D in that order. And it doesn't tell me exactly where they are. I just have to know that they're in order. So I can put them, anywhere I want as long as they're in order. So the directions say points A, B, C, D are collinear, and in that order, find BC. So here's what we're trying to find. Find segment BC, and they give us some information about the line segment. So they give us that BC is 2x minus 3. So it's a good idea to actually write that above there so you can see it, 2x minus 3. AB is 2x minus 1. So this piece right here is 2x minus 1. AD is 17. So the whole thing is 17. And then they gave us CD also is 2x plus 3. So that's all the information you need. So if you want to find BC, if you look at it, so you got to find 2x minus 3. Well, once you know x, you just plug x into 2x minus 3 and you'll know BC. So if you look at that line segment, you know that segment AB plus segment BC plus segment CD, all three of those pieces add up to 17. That's the segment addition postulate. So just write yourself an equation and solve it. So you have 2x minus 1 plus 2x minus 3 plus 2x plus 3 equals that total 17. Combine your like terms, looks like we have 6x minus 1. Looks like the minus 3 and the plus 3, you could actually kind of like just cross those off, couldn't you? So 2x, 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 used all those up. You get the minus 3 and the plus 3, those are gone. So 6x minus 1 equals that right side 17. So 6x is equal to 18. And then x is 3. So remember, you can't stop there because they asked what is segment BC. So you have to go back and answer the question. So segment BC is 2 times that 3 you just found, that x you just found, minus 3. So 6 minus 3 is 3. So there you have it, a couple examples from the assignment. So version 1 and version 2 are in this assignment. So they are pretty much going to be worked the same way. All right, there you go. Enjoy. Good luck.